Let's tackle first topic 1.1, all about the differentiation rules. So to rule number 1.2, so the power rule of finding the derivative of a function. So here's the definition. So if n stands for any real number, then the derivative denoted by d over dx of the function x raised to n. Again, our n is the power which stands as any real number is equal to n the power times x raised to n minus 1. So again, the power rule is equal to the product of n times x, where x raised to n minus 1. So to further understand, so note that always remember that the derivative of the identity function x is 1. So the derivative or d over dx of the identity function of x is always equal to 1. So always remember that one, since this derivative will be very helpful as you study the differentiation process further. So to further understand, so here's the following example. So example 02, find the derivative of each function. So first, we are going to find the derivative of our f of x is equals to x raised to 6. So using the power rule, so is equal to our f prime x here is equal to our n is 6. So 6 times x raised to n minus 1, where n is 6 minus 1 is equals to, simplify further. So that's 6x, 6 minus 1, that's 5. So the derivative of the function is equal to 6x raised to 5. So next is g of x is equals to x raised to 25. So find the derivative. So g prime x is equal to 25 Rn times x raised to 25 minus 1. So that's 25x raised to 24. Right? Yes. So next is find the derivative of h of t is equals to 1 over t raised to 3. So first, we are going to find the simplified form of this function. So 1 over t raised to 3 can be simplified to t raised to negative 3, right? Yes, so now we can now find the derivative h prime t is equal to negative 3 over n times t raised to negative 3 minus 1. Simplifying further, that's negative 3 t raised to negative 3 minus 1, that's negative 4, right? Yes, so can express that one into the simplest or the simplified form, that's equal to negative 3 over t raised to 4. So this will be down the final derivative of the given function. So note that in the broader context of differentiating function, it is advisable to express the function in the simplest form. So any questions? So now let's proceed to example number 3. Find the derivative of function p of t is equals to square root of t. So as we all know that square root, here's the solution rather. So as we all know that square root of t can be expressed as t raised to 1 half, since that's t raised to 1 over, yes, right? It can be expressed as t raised to 1 half. So then we can now find the derivative of the function applying the power rule. So our p prime t is equal to Rn is 1 half times t raised to 1 half minus 1. So applying the power rule, then we are going to, next step, we are going to simplify. So that's 1 half times t 1 half minus 1, that's negative 1 half, right? Yes. So it's equals to 1 half times. Express this one, so we are going to reciprocate this term or expression. So t raised to negative 1 half is equal to 1 over t raised to 1 half, right? Yes, so multiplying, so 1 over 2t raised to 1 half. So simplifying, so or the simplified form is our p prime t, or the derivative, is equals to 1 over 2 square root of t. So here's the final simplified answer. So therefore, we can say that the derivative of this function is this one. So now let's proceed